Hey everybody, I'm here with Andrew Henry at Henry Holsters, and we're gonna do another shop tour.
Welcome to Spencer, Indiana. We are an OEM holster supply shop and machine shop. So for our holster customers, we focus on appendix concealment holsters for mid to full-size weapons, especially with lights and optics. So we're primarily focused on people who carry a gun for a living. As an OEM, we make holster molds and holster products, including fully retail packaged OEM drop shipped stuff for other holster companies. And we also do machine shop work. So we have this building. It was built in 1991. We bought it in 2020. It was a stamping shop before we got here, and it's now our home, our machine shop, and we just had to add on to it because I was shocked that we filled the building up way faster than I expected. So let's head inside and take a look around. All right, so we have the orange wall here. Henry Holsters, orange is our color. Ben is our COO. He manages our website, a lot of our digital operations. Amanda, our office manager, is working from home today. But this small front office, we're not really an office-heavy space. Most of the building is manufacturing space. We have a small break room at the front and a small storage room with like refrigerator, snacks, and things in it. One of the things we plan to do in the future is add on more of an actual like kitchenette area and have a dishwasher. The ever-important coffee machine is right over here, and also this is our shop lean library. So the bottom shelf is a bunch of my books. The top shelf is a lot of the books that we recommend to the employees to read. Paul Akers' 2-Second Lean, we give a copy to every employee when they sign on, and we have these backpack vacs around in each bay.
Yeah, the infamous Milwaukee backpack vacs.
The famous Milwaukee backpack vac. In the morning, we 3S, we don't 5S, so we have about 15 minutes of sweeping, sorting, and standardizing first thing in the morning. Then we have a full team meeting. That's handled by a rotation. Our entire staff takes turns leading that meeting, and we go over, I'll show you the agenda for that meeting later. This is my office. So this is where I record the Lean Built podcast. This is where I do my admin work, brainstorming. It's one of the only spaces in the building I can close the door and be undisturbed for a few minutes, although since I'm right next to the main CNC bay, even with the doors closed, it's not super quiet. But it is nice to be able to have some space to go in and say, hey, for the next few minutes, I am unavailable. All of our design work happens here. Chris is our lead programmer and lead CNC machinist. He's working on some stuff for the Matsuura currently and building this crazy new liquid-cooled computer setup he's got going. We run 3 Bamboo Labs X1C printers. We have AMSs on all of them, and we've done a lot of little improvements like magnet tags to mark CF filament from a distance so we know, and then if one of these is in progress, we tag the handle so you can't accidentally send another program to that and crash it without removing the existing part. Our dryers right here for stuff that needs to be dried. These are a huge force multiplier for us in terms of quickly making, not primarily products, but lots and lots of little tools and experiments and fixtures and jigs. Like the ability to rapidly design something and then have it in your hand and usually be able to iterate it multiple times in a single day with feedback from the shop floor is really, really important.
Yeah, absolutely.
As a shop, we do almost all of our design work in Fusion. We do have a couple of seats of Inventor, a couple of seats of SolidWorks.
Is that safe to show?
Yep, that's safe to show. And then we have a remote team. We have a couple guys in Ohio who are part of our product design team. And so we have 4 or 5 meetings a week going over updating designs, keeping track of client needs, making sure prototypes and samples are getting shipped. And then this is our machining area. Obviously the newest, biggest thing is our Matsuura MX420. It's not running right this second. We are in the process of gradually building fixtures and moving jobs off our Speedio and R650 onto this machine. It's pretty awesome. Just watching this machine run puts a huge smile on my face. And you're gonna see a lot of content, not super high production value, but a lot of shot on my cell phone content of this machine over the next few months as we get more production jobs running on it. It's just so exciting to have palletized 5-axis capability. That has been a goal for a long, long time, and we're finally doing it. I mentioned to AJ before we started recording that the shop is a little bit in flux right now because we had to move a bunch of stuff to make room for this machine, and we're also just finishing and starting to move into a new addition at the back part of our building, which means a lot of things are shuffled around. Our Doosan dual spindle lathe and our Speedio and R650 handle metal parts production. We've got T200 rotaries on both of these brothers, and so we can do multi-sided work on those. The twin table brother machines, the R series, are incredible workhorses. We have 3 of them and we love them. especially when we're doing relatively short cycle work, you can balance some other operations in a cell right at the machine and have the operator working continuously, not being frantic. But if you have to do, if you're running 5-minute cycles and you have nothing to do in that 5 minutes, it gets really exhausting. But if you have a pretty even, consistent, steady, comfortable pace load of work to do, prepping the parts, taking them off, inspecting them, and then moving them on, you can keep the pace, like we say, we want the cruise control set at like 40 miles an hour and just keep going. This is my workspace. I do a lot of our product development in terms of mold design and mold testing. So I have a sample. This is a duplicate of our assembly benches. We have all of our standard
I can show
hardware.
this?
Yeah, sure.
Okay.
All of our standard hardware pieces, the various spacers and screw posts and all the things we use. This allows me to build assemblies of things that match up to what we would do in production without having to go interrupt somebody at a production bench and take over their workspace. So this Speedio, Mill 2, is basically mine. I'm pretty much the only one who runs this. We have it set up with one vise and one vacuum fixture, and a lot of our stuff just has a 4-pin pattern on the bottom, and we can quickly, if I need to recut something on this mold, pop it down there, vacuum it down, recut a few features, and take it back off. It's very flexible, and we do a lot of prototyping of molds in high-density plastic because it's quick and cheap, easy to recut, easy to mess with, and allows us to iterate rapidly and get to a better fitting product without a lot of time spent in cycle. So we love Speedios. They've been awesome for us. My first 2 machines were Speedios, and they still do a ton of work for us. For metal parts production, there are advantages to having more RPM, to having more tools, to having a bigger spindle taper. But for what we've done over the years, these have been awesome. And one of the things that's nice, especially for a lot of dry machining, is these have no augers. Everything is cleared out with gravity, and so it's super easy to just grab a brush and sweep plastic chips down and then scrape them out the back. So keeping these machines clean and orderly, nice and tidy.
So talk to me about your drill setup here, because you have more than average.
Yeah, so I'm a big fan. Back in the day when I first started buying hand tools, I got myself some Hitachi 12-volt drill driver sets and loved them, and have continued to buy them because for what we're doing, I don't need a hammer drill, I don't need 18 volts. I do want something that can stand on a bench, so a lot of the little small 12 volts that have a cylindrical battery where you have to lay them flat, I don't like those as much. But these are a great size, they're not super taxing to carry all day. And at my station, I have a lot of standard bits. And rather than having those bits be in a tray and having to change them out, when I'm working on something, I want to be able to simply reach over and pick up the tool I need, use it, and put it back. And if I'm working on something where I have to put some screws through the part to hold it down, we have our own little magnetic drill docks that fit these, and that puts it right here at the entrance to the machine. So you open and close the door, it's not in your way. You take your screws in and out of the part, and you're right there. And then when you're done with that, goes right away, and that goes back on the dock. That kind of standardization where we look at the things that we touch frequently and then just take away any extra steps in that process, it makes a really big difference in the ease with which I can step into the station and work. And nobody steals these drivers. We have plenty in other places. These ones live here, and I don't have to go hunting them down, which is really nice. We did just move our bandsaw, so we have a roller rack and we have our Tormac bandsaw up here, which we like a lot. It's our first auto saw.
On a riser.
On a little bit, yeah, we built our own cart out of 80/20. We wanted to have the whole thing. I didn't want that back folding leg on its own support. Keeping everything level to the roller tray made a lot more sense if we built this whole thing as a solid unit, and then we can wheel it around more easily if we need to. We've added little magnet trays, like our stop has a spot to live. And we stick a tape measure on here and a calculator on here. Just little quality of life things make a big difference. Our SOPs for the saw are all photoed and written out, and they're laminated and they're stored right here at the saw. So if somebody needs a refresher, they don't have to track down the person who knows the information and bug them. They can just read the documentation.
Do you run that with coolant, or does it stay dry? Really?
Yep.
And there's not a puddle on the floor by yours?
No.
How do you keep the coolant in it? That's a problem I have on mine.
So we actually typically, we will put a fall-off bucket for parts with a Kydex shield. that
Okay.
keeps a lot of the splashing down. It's kind of a fan-shaped thing, so anything that hits it funnels into the bucket, and we keep some liquid in that bucket, usually some weak coolant, and at the end of that job, we then top the tank on the saw back
Very
up
cool.
or put it into one of the machines because we're using the same coolant there. This is our shipping area. We have our own branded products shipped out of here, but we also ship on behalf of other companies like Filster and Modus Fire Rescue. And so we have a bunch of angled racks. We keep minimum quantities of inventory. A lot of these have an on-shelf maximum of not more than 20 pieces, some as few as 5 pieces. And all the holsters that are here, we can build from scratch and restock as finished inventory in one business day. And so we're not having to build big batches to make sure we have days worth of inventory. We can respond to real-time demand from website orders and just make sure, hey, if we sell all these today, we'll make 8 more of them, top up the shelf. And even if a customer happens to order in that 3-hour window when the shelf was physically empty, they order on a Tuesday afternoon and their order will still ship Wednesday morning.
Yeah.
And as far as they're concerned, it existed. It was in stock. Our packing station is basically a 2-part operation. We have an iPad with a Bluetooth scanner. We'll print off a small stack of packing slips. They rack here, and then you'll pull bins down, scan into your packing slip, fill up your bin, and then drop it on the roller, and it will head down to the packaging station. Everything is scanned to verify, and this is our own software that we're using that integrates with ShipStation that allows us to have a simple interface. If you scan the right or wrong thing, it'll give you a positive or negative tone audibly. And then at our actual shipping station, let's run a live order. Step off to my left here real quick.
Okay.
So if you ship in ShipStation at all,
I don't want to show any customer information, so
That's
tell
fair.
me if I'm safe to wrap around.
You're fine. I'll give me 1 second. Where are we? Come on. So if you look briefly over here, you can see the screen's very full. Your typical ShipStation order grid has a lot of info on it. We want a much more simplified interface. So this is our software, and all you would do would be take a packing slip, scan into it.
Ground advantage.
It'll enunciate your shipping class at you. Then you stick this stuff on the scale. I'm going to cover up that customer's info. And some swag. We have a live camera feed because there's an overhead document camera here over the scale. And then this one button integrates everything here. So pushing that button saves the weight, buys the label, prints the postage, takes a picture, and then attaches the photo and the tracking info to an email and sends it to the customer. And then we have a little single sheet document folder here so you're not having to hand fold packing slips. And then all that goes in a package and out the door. And building that streamlined of a system where all those parts you touch are as automated as possible. You close that up, and then we have a little vacuum for those staticky bits that cling to your hand.
That's awesome.
That's one of the ones that really gets people to crack up when they first see it.
As someone who has shipped hundreds of packages in a day before, where does it go? Oh, there's like a dust collector kind of thing over there.
Yep.
Wow, that is super cool.
Yeah, so that and that is motion activated. So there's actually a breaker beam here at each station, and as soon as you pull packaging, it turns on that vacuum so that you can have that little piece. Because we used to have trash bins under the benches, and you'd always be like trying to shake off that staticky piece, and it was just extra hassle. We ship a lot with US Mail, we ship a lot with UPS. We don't ship hardly at all with FedEx, but US Mail comes and picks up usually around lunchtime, and then we make a run at the end of the day too to make sure that any packages that we finished packing that day always leave. I really don't like to have any packages stay in process overnight. We want to be able to, if the customer gets a tracking number from us, their package needs to be in transit that day. As far as work in process, WIP, as a lean shop, we're trying to keep WIP to a minimum. So this is pretty much all of our WIP of in-process holster shells. And these are all fresh off the CNC. So these are flat, they've been cut, they have brand and gun model engraving on them.
Okay.
The edges are sharp, so they will need to be finished, buffed, and then we strip heat the center and fold the holster shell shut to make a complete shape. We use Scotch-Brite wheels.
Okay.
And this one switch powers the buffer and turns on the dust collection. We have a status lamp for the dust collector because it's quiet enough that if you don't notice it's running, it can stay on. And then this buffing process I'll just do one side of the shell. All we're doing is trying to break the edge, take the little corner off. And so it's relatively quick and easy. It's one of these two steps are some of the most skilled manual work in the shop. There's no reasonably cost-effective way for us to automate this. These parts are flexible and they're very thin. And we looked at different kinds of auto buffing with robotic systems that usually relied on electrical current draw feedback to determine how hard the robot is feeding the part into the wheel. These parts are so lightweight that before there's almost any reasonable deviation in the current, you've just ripped the part on the wheel. So we ended up abandoning that pursuit. For now, we may revisit it. Then those shells come over here and they get put in this little top and bottom strip heater, which has time and temperature settings, and then you fold the shell around a 3D printed slug. We have 3D printed slugs for every gun model we make, and then it gets clamped and put in our very, very high-end plywood, sheet metal, and plastic mesh cooling rack. Then you would use a kick press to install some metal eyelets, grommets basically. And then if there's any touch-up buffing needed, you touch it up, and then we have a blowdown station, which has an ionizing air gun. And so this is a 110 circuit that kills the static charge on your plastic parts. This switch charges the gun, turns on the dust collector, and opens the gate. And then you blow your parts off down into that dust collection. And then when you switch it off, there's a 1 minute timer. So the dust collection continues to cycle for a minute to finish drawing dust through the system before it shuts off. This is our lean supplies area and our label making area. So we have a number of different label makers with different size and color labels available. And then tape and zip ties and magnet tape and portable label printers and Kaizen foam supplies and all the various bits and bobs of things you could use to make small lean improvements at your workstation. And these are here available to the employees anytime. This area is due for a reorganization. As we add more supplies to it, we've actually kind of topped out the shelf space. But having that stuff available for people to be able to stop production, come over here, get some things, and make a lean improvement in their space is really powerful. And then the largest part of our building is Bay 3. This is where all of our holster shell production and holster assembly, sewing, and laser operations happen. We've got two R450s back here. These machines are twins, they're identical. And we use these for all of our holster shell production. So if we step over to Mill 5, we can look in the window and see what's going on here. So we just finished trimming this part. This is a dual magazine carrier for a SIG P320. And we put in a formed part. We'll have a part in just a second. Hey, okay. Josh, can you run the next part?
Yeah.
Oh. We'll edit this part out. He just ran a dry part. He was distracted.
So these are the infamous mills without doors on the front, right?
Yes. Yes. The ones that Yamason got in hot water over. Yes.
Oh, I didn't know that. I mean, actually seeing this cut. Oh, I guess there wouldn't be coolant regardless. Never mind.
Yeah, no coolant.
That's nice.
So we have pre-cut stock, which we cut on our pneumatic shear.
Okay.
It gets loaded into a heat press. The hot plastic comes out and gets pressed in a mold, loaded in the pneumatic press, and then put on a cooling rack. And then those cool parts get loaded on a vacuum fixture on the table. The alignment pins keep us centered on the part, and they also locate the male and female molds together. Pressure and cycle on the pneumatic press are set at the beginning of the job. And we try to balance this out so the CNC cycle and the heating and cooling cycle roughly match up. So we got a live part in the CNC now,
okay,
and we can watch it getting cut. We're running Regal fix holders here, so we have through spindle air blasts coming down around the tool to make sure we don't get plastic chip welding around the shank of the tools. And then we're going to trace around the part, cut off the excess material. We could feed faster, but we're trying to get a clean enough surface finish that we have minimal edge finishing and buffing work to do by hand. And there's no point running this cycle any faster than the next part will be pressed and cooled. So we detune a lot of these trimming cycles to get the best quality out of the part and eliminate any other handwork later. So we've left the center tab to keep the two parts joined until they're mostly edged, and then we clip out that center tab. And then we have an air knife that comes over and blows off the part. That was a more recent lean improvement. We've been wanting to do it for a long time. But since the person at the load door is still prepping the next part, there's no reason to make them also manually blow off this table when it comes out, and it keeps more of the mess on this side of the bulkhead. And your next part comes in, machine goes right back into cycle. These machines, the twin table machines are awesome because you can have the operator working and the machine basically keeps cutting continuously. We pre-cut a lot of our stock on this pneumatic shear, so we're usually working with 4x4 foot sheets. We use magnetic stops to set our cuts, so we're not having anything we have to like unclamp or have a hex wrench. So you just drop it and then slide your sheet through and foot pedal it and cut your part. And then a lot of parts need some alignment holes drilled in them. So we have a drill press set up, and rather than constantly jogging this around, we just have pre-made templates that match our standard widths. So if I was just drilling 9-inch wide stock and now I'm going to drill 13-inch wide stock, I leave the fence where it is and I change out the extension, and that way I have settings, not adjustments. And those are all based on a parametric model that we have in Fusion, where you just say, this is my stock size, and it immediately builds and labels the appropriate arm extension for this little jig. Yeah, SMED was a very influential book for me.
Quick question on that. So I saw there were some like red knob looking things.
Yes. I'll show you
those
over here.
are secondary to vacuum work holding, correct?
Yeah.
Or is that the only work holding on those?
You're talking about these guys.
Yeah. Oh, those are just magnets.
They're
not
just magnets.
Knobs.
No,
Okay.
they're not knobs. We 3D print press fit sleeves for them because it's much easier to get them off and handle them if you have a little bit of texture on the outside. So these are just 3/8 by 3/8 N52 rare earth magnets. They're fairly strong. We use them for two reasons. On some fixtures, you'll see this, we have vacuum gasketed zones under each half of the part, but we also have magnets in the wings because there isn't enough surface area there to get a functioning vacuum zone. And vacuum is awesome, except it's either 100% working or it fails.
Yep.
And as soon as you lift or flex the part and your vacuum seal breaks, you're unconstrained. So the magnets do two things for us. They provide some vibration dampening, and they are a secondary form of work holding that's independent of the vacuum. Even if the vacuum fails, that buys the operator time to e-stop the machine and not lose the part.
Fail safely.
Yeah, fail safely rather than throwing things around and busting stuff. And then on the fixtures themselves, in between cycles, we have little docking stations where we just flush fit a screw head. So you would load your part on here and then just drop these two guys, and they would both vacuum to the appropriate wing, and then when you're done, you take them off and stick them there rather than taking them out and setting them down or sticking them to the machine. We want everything to be basically where it needs to be. So the bolts we use to hold these fixtures down live in these magnet docks. The hex key you need to use to remove them lives right here. The air gun to blow things off floats on a bungee over the pallet because we used to have it on a hook outside the machine. You'd always be picking it up and putting it down, and half the time you drop it. And because we always need it in the same place and everything here is standardized, there's no reason to not have the air gun right where it needs to be, so you don't even have to pick it up and put it down. You just trigger it and then let it hang. We did replace our safety door switches with light curtains. We had to replace the factory handles with 3D printed low profile handles that fit inside the light curtain. But because we are dry machining and there's no mist management to do, there's no reason why we need to keep the entire machine enclosure closed. And so this means, going to light curtains means hundreds less door cycles a day for each operator at each of these machines, and that is a real net gain. This is our sewing and assembly area. We also have some laser cutting operations, which are currently down because we're rerouting our fume extraction. This is a great example of settings, not adjustments. So this is a Sheffield hot roll cutter. We use it for cutting nylon and poly webbing for different belt components we sew. But you have to put in quantity to run, length, speed for the roller feed, how long to dwell the knife and your hot knife temperature. And we used to have it just on a sheet of notebook paper. Then we made a laminated sheet that had your recipes on it. And then we switched to just 3D printed templates that actually drop over the control face, and you just make the numbers match by field. So rather than looking at this, memory storing that number, entering it, looking at the next thing, entering it, you just go, 6.9, 30, 1, 525, and then you take this off and hang it, and you are ready to run. And these are color coded by project, and those same color codes also match the guides that set our spacing for the infeeds. So if we're running red, I'd put that red guard on there, I'd put this red recipe on here, and then set everything up so that I'm not having to sit here and tinker with this. I just want it to be set.
So all this is doing is moving data straight to where you're entering it.
Yes, we want to have the buttons and the field that you're viewing be directly adjacent to the information you're entering. It's just an overlay
That's
template.
super slick, yeah.
And we showed it to the company that makes the machine, and they're like, that's a really great idea. And I'm like, would you like to share the idea to any of your customers? And they're like, nah.
Sounds about right.
Our CNC sewing machine over here we call Optimus Prime. It uses acrylic templates that allow us to align multiple pieces of elastic and do both our straight line and our zigzag sewing in a single operation. This is a place we kind of have to do a little bit of batch processing just because loading and unloading the fixture is a bit time consuming. And the machine work area is such that we can pretty efficiently get 4 parts on there. It also means that the cycles are a little longer, so when 4 are running, our operator, in this case Christian, can take the 4 previous pieces and clean off all the loose threads and inspect them and have a little bit of a longer cadence to those cycles. In our laser area,
which is still in flux, right?
yeah, we're not running anything right here today. We have 2 identical Boss 3x5 foot lasers. We have taken the honeycombs out of them, left the slats in, left mostly aluminum slats, but replaced a few of them with steel so we can use our own little magnet toe clamps. So we can clamp these out in the cutting area and use them to hold down the edges of wavier sheets. And also the slats make it way easier to clean off the parts afterwards. We get a lot of little pieces that tend to weld, like these little plastic pieces will stick to the slats. If you have honeycomb, you have to vac them all off and remove them from the top. If you have slats, you can just take a squeegee and just drag the slats, and any parts that are welded that stick up, you just knock off and they fall through. And so in between cycles, cleaning time is dramatically reduced. On the programming side though, you then have to account for making sure the longer axis of your laser cut part is perpendicular to your slats, otherwise you get more fall throughs. So it's all trade-offs. Everything's trade-offs.
Does your laser software account for where the slats are?
No.
Okay. I used to run lasers in a sheet metal shop.
Yeah.
And it would know where the slats were for that very reason. It calculates center of mass of the part, and it'd be smart enough to place it so it wouldn't fall in.
That's fancy. That's beyond what we have currently. We also 3D print go, no-go gauges. So for a lot of our parts, after they come off the laser, they need to be clean because they're a little bit dusty anyway. And this provides both a fixture to hold sets of parts while you vacuum them, but also verifies the size and location of all the slots and holes to make sure that if for any reason you missed something and took an incomplete part off, it doesn't make it out the door to the customer. So because they go through that as part of the cleaning process, we're also doing 100% inspection. And normally the operator will be running both machines and then inspecting and cleaning parts from the previous cycle all at the same time. And then one of my employees had the idea of making the lights in this cell controllable by the operator because it's way easier to see inside the machine if you can reduce the amount of glare off the glass while you're in cycle, which was a great idea. And I didn't think of it. So I love the kinds of improvements that people who work in the space come up with. And anytime I spend time working in the area, I was the first laser operator in our company, but I still laser prototypes, and there are still plenty of things remaining to be improved everywhere in the shop. I'm going to show you our addition real quick. This is our soon-to-be mechanical room and storage space. So we just got this finished a couple weeks ago, and Brian and Liam are building out our mechanical room. And at that point, our air compressors, dust collection will all move into there. that'll help control some noise in the workspace. It'll allow us to more easily vent the heat from those machines out and not have to fight the AC. And Brian, who is our facilities manager, has just always wanted to have a mechanical room. So we're finally giving him his own mechanical room. You see that blue light over there? I really like visual indicators, as much as possible, visual indicators that are asynchronous. We stole this idea from FastCap. One of his shop tour videos, Paul Akers, explained that they have some cells where they build custom products occasionally on demand, and anytime there's a packing slip, work order for that cell, they just drop it in a tray that has a motion sensor in it, which is exactly what we do here. If there's a packing slip for a custom build, we have a little sensor built in here, and as soon as you drop that packing slip in here, that lamp goes on, and any of the employees who are trained on this bench to build those custom products know there's a work order here waiting. All their ingredients and precursor parts are all right here. Then they just grab the various things they need and they build that unique custom order and it ships out. So those complete custom holster builds, which when I say custom, it's a custom configuration of existing options. There are enough possible variations and permutations that we can't possibly inventory every possible combination, because when you add a holster and a faceplate and a belt system and all those things have sizing involved, the number of possible variations is ridiculously high. But we build those and ship those on demand same day. We used to have a little disco lamp, but it was a little bit distracting, and so we went to just a standard solid color lamp. At our assembly benches, this is very much like my prototype bench up front. A lot of the same color coding applies. We use Fulcrum ERP, and so all the employees are working from iPads. Fulcrum is nice for us in that it is pretty mobile friendly. The visual layout and graphics are pretty mobile friendly. All these bins are color coded to the overstock bins behind you that we refill them from. So if I needed to get flathead screws in a blue bin, there's only one blue labeled bin of flathead screws over there, and that makes it harder to get wrong. It's not impossible, but it's harder. And we keep only the tools you need at this area. So we have little magnet docks, and sometimes tools come and go, but even basic things like we want to be able to pick up tools in the orientation we use them and put them back. When we're working with nylon belt webbing material, occasionally you'll get an end that frays a little bit, and so we keep a lighter at the assembly stations in case you need to just singe off a couple of loose threads. You don't have to go wander away somewhere to find that. You just pick it up, clean it up, and put it away. So this is one of our bar tack machines. We use it for sewing fairly narrow nylon webbing. Getting narrow webbing that wants to be kind of twisty and floppy to lay flat under the sewing shoe is always a challenge. And so I relentlessly steal ideas from guys like Uriel Eisen at Austere Manufacturing. These little fixtures just pin on to the safety guards, and we have multiple versions for different sizes of webbing. You just press it on, and then we drop just 2 dowel pins in these holes at the back so that it can't shift off. But it takes seconds to change over, and those are also color coded and have made it way easier for our operators to sew these parts with a low defect rate. When we first started sewing them and we're working completely manually to line things up, we had like a 25 or 30% reject rate. And once we got fixtures designed, that reject rate dropped dramatically. You can also do cool things like include hinges and magnets. So this is a more complicated fixture that you load multiple parts in, and then it has magnet gates that lock those parts down. We stole this from Uriel. And also has anti-friction pins built in so your webbing can't walk around in the fixture. So you load all your parts, snap it, and then this feeds under the shoe and you stitch it. Still working on making that process even easier to handle and work on. We're always changing things at these stations. When we're dealing with narrow webbing, this is an easy way for the operator to have a place to hang their parts, and then this whole bar can just transfer to the next station with all the parts on it, rather than having to put them into a bin and have them turn into a rat's nest. So we have transfer bars here, so you can take 50 at a set and they live on a bar. They're all in order, they can't get tangled, and it also makes doing a quick visual inventory of how many of those I have in stock really easy. Count the bars times 50 and I'm done. Assembly stations, we try to keep them as minimal as possible. So at this assembly station, there's only 2 sets of hardware being used. Either this set or this set. And whichever set you're not using, cover. So you don't even have the option of accidentally going on autopilot and grabbing from the wrong bin. A lot of our benches are adjustable height so that the user can crank them up or crank them down, because we have a variety of heights of operators. And we want the work table to be at an optimal height for you. This is high for me because I'm going to be drilling here. So I'd probably lower this 3 inches and have the work be at a more comfortable neutral height for me.
Is that there? Is that attached?
That's just rubber gasket like you would see like at a garage door. And that's just to keep small things from as easily sliding off the bench and falling on the floor. I really, really like those kinds of inexpensive, simple improvements. Like this is like $1's worth of foam gasket. And if it saves you from having to pick up hardware 5 or 10 times a day, super worth it. I mentioned our morning meetings. We have those here 5 days a week. And we have a really simple agenda, which you can take a look at right here.
So this is standard every day?
This is standard every day. This is our morning meeting template, which we update anytime we have a better idea of how to do it or have something we need to add or include. We change the template. Our remote team will always zoom in to that TV so that our home team can see them all and they can see us. We broadcast them from that iPad so they can see the meeting and we can see them.
So every morning everyone's here, including remote?
Our remote employees are here Monday, Wednesday, Friday
Okay.
for our morning meeting. And Tuesday, Thursday, they are not in. But we go over, we always have a couple of sample defects from production the previous day. No matter how lean your production gets, there's always going to be some defects. You know, it used to be that we would have large quantities of defects, and now the quantities are smaller and smaller and smaller. But every time we have a defect, we typically take it out, pass it around, everybody handles it, and then whoever turned it in has a chance to explain, okay, what happened, what station did it happen at, what machine was running, what was the problem, and then we all discuss together, how can we address that process to make that defect harder to happen in the future? And sometimes it's really obvious what we need to do, and sometimes it's not clear what we should do, and it obviously warrants more digging into. And then we usually pick a couple of people and say, hey, can the 2 of you go look at that process when it runs again today and see if we can come up with a clearer idea of what we can change to make that defect harder or impossible to have happen again.
Do you follow any sort of troubleshooting process?
We use the 5 whys analysis pretty often. It's also helpful to just ask the person who was working in the process to describe in as much detail what else they were doing. Like, it's the classic, did you leave the food on the stove for too long? If you've got too many things going on, maybe all we need to do to fix the process is do fewer things at that station. So getting more of a picture of what was actually happening, and there is no substitute for actually going to the Gemba and watching the operation run and seeing where's the person standing, where's the in feed of the work, where's the out feed of the work, what are they touching, what are they looking at, how much noise is there, what all is going on. Because a lot of times there isn't one single cause. There's a couple of factors that contribute, and we can usually address each of those separately and make the whole thing work better. Lean morning meetings, when we first started them, I led them every day, and that was fine. It was definitely helpful, but it's a different kind of participation when each person knows they're going to be taking a turn this month leading a morning meeting. And one of the things we do is we have a couple of laminated sheets that have different lean phrases and concepts on them, and each person in part of the meeting will pick one of those and explain it. We might talk about the 8 wastes, or talk about the idea of, like this one, your head is not a to-do list. If you've got a bunch of things to do, we need a process or a system that captures those so we don't lose them and rely on memory, because you're using up RAM all the time to keep those things stored when you could be using that mental energy and focus to be doing better work. Lean morning meetings, I think 3S'ing and lean morning meetings are a great place for any shop that's interested in lean to start. If you set aside time at the beginning of the day to clean and standardize. It's not just cleaning. I like Ryan Tierney saying, cleaning is not leaning necessarily. It's part of it, but it's not the whole thing. Dedicating time at the beginning of the morning when everybody's had their coffee and no one is in the thick of the work yet, it's really productive time to see what's going on. And being able to see waste and see opportunities for improvements is the name of the game. Understanding lean concepts isn't helpful if you can't actually interact with a work environment and see waste and problems and understand them and start to approach solving them. So the goal is refine everybody's ability to see and then give them conceptual tools to address those problems and defects and make them better. So I've really been enjoying our company being on a lean journey for years now. It's gratifying to see. We use the phrase the battle days to describe how we used to do things. And compared to how we used to do a lot of the processes in the shop, the current way is kind of miraculous, honestly, in the way that it feels. But we're always remembering how we did things in the battle days. Compared to how we do shipping now, how I used to ship orders in the battle days is ridiculous. But it's still helpful to remember that because it has been hundreds of improvements to get from there to here.
So do you have any quick improvements we could look at if we've seen everything? Do you have any cool examples other than the ones we've already covered?
Yeah, let me think for a second. There's some all over the place. I'll show you a cool machine that we just got. So some of these narrow nylon webbing pieces have to get a piece of heat shrink on them. And we were initially doing that with just a hot air, a little heat gun mounted on the bench, and you'd hold your work over it, and it relied on the operator to keep a careful eye on it to make sure you didn't singe or melt the material, but also make sure the heat shrink got fully closed. And we were also finding that some of the heat shrink things were getting kind of stuck and they were hard to get your webbing through. So we built a little jig here that you just press your part on and it rounds it so it's easy to feed your webbing. And then we found this cool machine which uses light, a very hot lamp. So you load your part in there, you hold it, and you foot switch it, and you have a time and power setting on here. So rather than just having the heat gun on and, you know, roasting your marshmallow till it's burnt, you load the part in, you hit the foot switch, and it cycles once, and it gives us exactly the right amount of heat. But it had this guard to protect you from glare that extended really far down and was kind of awkward to load your parts up under. And so one of the employees said, hey, can we turn the machine on an angle? It was designed to sit on a table like this. Can we turn the machine on an angle so I have better visibility into the actual heat zone and I can see the heat shrink working? And then can we cut the guard back so that it only shields my eyes at that appropriate angle, but doesn't interfere with my hands loading? And then we move this directly here. So you just go pop this, feed your webbing into here, foot switch, and out. And so those 3 or 4 lean improvements, this jig, that cut, the angle, were all created by the operators using this machine and saying, I'm spending extra time or effort doing this, or I'm struggling with this, let's fix it. And it takes only a few minutes to do each of those things, and the end result is we shave a significant amount of time and hassle out of that cycle, and we make hundreds of those a day.
So a lot of the people who have shops that are, you know, buried in work, they're super busy, they want to be more lean, they know the benefits. How do you find the time? How do you make the time to actually implement it?
Well, there are 2 things on that. Let's walk to a quieter spot while I talk. Yeah. The first one is, it is really valuable to get some easy wins, to find little things. This is why one of the first lean phrases we teach new employees is fix what bugs you. Because whatever you're doing in the shop, whether you are operating a 5-axis machine or you are building hardware kits, if there are things that bug you and you can fix them, the gratification that comes from, hey, this was annoying and now it's not. This took 10 extra seconds and now it doesn't. I'm wasting less of my time on this. That feels really good. Obviously, there are some major projects, like we're redoing the overall layout in all of Bay 3. That's not a 2-second lean improvement.
Yeah.
That is a couple of weeks of planning and sandboxing, and we did a bunch of laser cut scale models of all the different stations and just did sand tables of how we could do the layout and then talked about the flow. So there are some projects that require a lot more investment of time and energy and money, but getting in the habit of making those like 2 to 5 minute improvements, they really do add up. And the way we share them around in the shop is we have a shop-wide signal chat. Everyone, including our remote employees, are all on it. And when we make improvements, we take a short photo or video and a write-up and send it out to the whole team so everybody sees it. And that does 3 things. First, it celebrates wins, and it acknowledges the creativity of people actually solving the problems, but it also shares the ideas around, because oftentimes a good improvement at this station is actually relevant or applicable to some other similar station. And if that other person doesn't see it, they won't know about it. But oftentimes we've seen a thing and gone, oh, that's a really great idea. We should also do that here and here and here. And then that improvement multiplies itself quickly across the shop. And so having a way to share ideas and improvements around the shop is critical. But there is no substitute for leading from the top on this. As an owner, as a shop manager, if you tell your people that you want them to do lean, but they don't see you doing lean, they won't do lean. And so I am the loudest, most consistent advocate for lean improvements in our shop. I'm the one who is most excited, especially when we have new employees come in. When they get their first couple improvements that we show off in the shop chat, I am really focused on encouraging them and then spending some time with them, helping them understand what other kinds of improvements they can start to get into. Because once you get a person with a little bit of momentum, we have some employees who are making improvements every single day. Others, less frequently. I try to make 1 or 2 basically every day. They're often in my workspace, so they don't directly impact most of the rest of the staff. But that's a muscle I want to be flexing all the time so that I'm in the habit of seeing a thing, recognizing an opportunity, and immediately seizing it and making the improvement.
All right, well, anything else we should cover?
There's enormous there's enormous value in standardization in many, many surprising ways. Even standardizing which kinds of wrenches you use and what type of hex keys you have at the machine. And we standardized on these Hitachi 12-volt drill drivers, and they're all over the shop, so we can have shared charging stations and transferable batteries everywhere. We don't have like, well, this bench has got Milwaukee, and that bench has got Bosch, and that bench has got Porter cable. It isn't that we couldn't potentially get a slightly better performance out of certain specialized tools, but standardizing takes all the thought and hassle out of that completely. And the amount of time and energy that I spend as an owner, especially, keeping track of things that could be standardized away is a significant drain on my attention, my focus, my productivity. And every time we've standardized something, it always feels like, oh, that's better now. Why did we not standardize that sooner?
Yep.
So easy wins, standardization, encourage your people, really lead with enthusiasm about lean. And the end result is it should make everyone's work easier and better, make the company more profitable, make the deadlines, the hassle, the running around in a panic because you're behind on things, make that less. Jay Pearson says that they are pursuing peace. And our shop is much more peaceful now than it was 3 years ago, even though we're doing a much higher volume of work than we were, because many of the things that just blew up or fell apart or caused problems or caused panic are gone now. And it really is, it's gratifying. It's nicer to be at work when work is lean.
Well, thank you. I appreciate your time. This has been so much fun.
Yep. Have a safe drive back.